Welcome, welcome to the lecture number 12. In previous lecture, we have seen the property number 7. Now, in this lecture, we are going to study the last property of the Laplace transform, that is property number 8. The name of this property is Laplace transform by definition. Laplace transform by definition. Okay, now what is this? So here we know that Laplace transform of f of t is equal to, what is formula? Integration from s to infinity, 0 to infinity, integration from 0 to infinity e raised to minus st into f of t dt. Okay, so this is the formula of the Laplace transform. By using this formula, we can solve some numericals. Okay, now there are two methods in this. First is type 1, that is by using direct formula. Okay, now how to use this property? Look at this. Find, example number 1, find Laplace transform of f of t if f of t is equal to 1 plus t, okay, for 0 is less than t less than 1, and that is equal to 0 for t is greater than 1. Now this is the example, and we have to solve this example by using definition of the Laplace transform. Now how to find out? Look at this. So given f of t is equal to t plus 1 or 1 plus t, we can write this. 0 is less than t less than 1, and that is equal to 0 for t is greater than 1. Now we know that Laplace transform of f of t is equal to integration from 0 to infinity e raised to minus st into f of t into dt. Okay, so now just what we have to do, we have to put the values of f of t. Just we have to put the value of f of t here, and we can solve. How to find? Look at this. So that is equal to integration from 0 to, so this f of t is divided into two parts. This f of t is t plus 1 for 0 to 1, and for 1 to infinity the value of that function is 0. So now put this value here. So for 0 to 1 e raised to minus st into f of t is t plus 1 into dt plus integration from 1 to infinity e raised to minus st into 0 into dt. So this term will be 0. Okay, so now just we have to solve this. So how to solve this? So here integration from 0 to 1 e raised to minus st into t plus 1 into dt. Okay, now we have to solve this integration. So now to solve this integration, what we have to do? We have to use the basic formula. Which formula? So integration of u into v rule. Integration of u into v. Okay. Integration of u into v. Nth formula, that is equal to u as it is v1 minus u dash v2 plus u double dash v3 minus like this. Okay. So this is the formula. Now which we have to take, which one is the u and which one is the v. So to find u and v, so we have to use here Liat rule, L-I-A-T-E rule. What is L? L means logarithm. So now is there any logarithm term? No. Is there any inverse term? No. Is there any algebraic term? Yes. So this is algebraic term, so therefore you have to take it as u and this as v. Okay. So now we got u as t plus 1 and v as e raised to minus st. Now put these values in this formula and find out the answer. What we get? That is equal to so u as it is, t plus 1 as it is, integration of e raised to minus st. v1 means what? Integration of e raised to minus st. So what is that? E raised to minus st upon minus s bracket close minus derivative of this. So derivative of this is 1 into again integration of this. So e raised to minus st upon minus s and already minus s minus minus plus s square. Limit from 0 to 1. Okay, limit from 0 to 1. Now that is equal to. Now solve this. So if you simplify this, what we get? If you put upper limit in place of t, what we get here? T plus 1 plus 1 is 2 into. Here what we get? E raised to minus s upon minus s minus e raised to minus s upon s square. Okay, this is upper limit minus lower limit. So here t, that is 0 plus 1, it will be 1 in bracket e raised to 0 1 upon this minus s minus minus plus e raised to 0 divided by s square. Okay, now simplify this. So minus 2 e raised to minus s upon s minus e raised to minus s upon s square minus minus plus 1 upon s plus 1 upon s square. Okay, so finally we can write this as, here we can take denominator common at s square. So what we get here? If you divide by this s to this s square, then we will get s. So multiply by that s to this numerator. So 2s into e raised to minus s minus e raised to minus s plus s divided by s will be, that is again s into s plus 1. Okay, so this is the answer. This is your f of s. Okay, so by using definition we can find the Laplace transform of such type of examples. Got it? So I hope you understand this. Now let us take example number 2. These examples you can solve at home or let us solve one example. One more example we will solve here. Find Laplace transform of f of t. Okay, Laplace transform f of t if f of t is equal to t for 0 is less than t less than 1 is equal to t square 1 is less than t less than 2 and is equal to 0 for t is greater than 2. So this is the example you have to solve by using definition of the Laplace transform. Okay, so now how to solve this? Look at this. Given f of t is equal to t 0 is less than t less than 1 is equal to t square 1 is less than t less than 2 is equal to 0 for t is greater than 2. Now, by using definition of Laplace transform, what is that? Laplace transform of f of t is equal to integration from 0 to infinity e raised to minus st into f of t dt. Now this f of t is divided into 3 parts, 1, 2, 3. Now how we can write this as? So that is equal to integration from 0 to 1 e raised to minus st into f of t is t dt plus integration from 1 to 2, for 1 to 2 is e raised to minus st into t square into dt plus for 2 to infinity e raised to minus st into it is 0 dt. So definitely this term will get cancelled, that is 0. Okay, so now next is, now you have to solve this. So how to solve this? So here by using that formula, here it will be u, this is v, this will be u and this will be v. So by using integration of u into v we can solve this. Okay, so let us see how to solve. Okay, now that is equal to integration from 0 to 1 e raised to minus st into t into dt first, and second 1 to 2 e raised to minus st into t square into dt. So we have to solve these two expressions. So that is equal to, so u as it is into integration of e raised to minus st e raised to minus st upon minus s minus derivative of t 1 integration of this e raised to minus st upon minus again minus s and this minus s, so minus minus plus s square, limit from 0 to 1 plus. Now for this t square as it is integration of e raised to minus st upon minus s minus derivative of t square is 2t e raised to minus st upon s square plus again derivative of this, that will be 2, again integration of this e raised to minus st upon minus s cube, limit from 1 to 2. Okay, now after that again if you again take derivative of this 2, that will be 0, that's why we have to stop here. Now just simplify this first and after that we will solve. So this minus t e raised to minus st upon s minus e raised to minus st upon s square, limit from 0 to 1 plus, okay, plus here minus t square e raised to minus st upon s minus 2t e raised to minus st upon s square plus minus minus 2 e raised to minus st upon s cube, limit from 1 to 2, right? Now put upper limit minus lower limit. So here minus 1 e raised to minus s upon s minus e raised to minus s upon s square, this is upper limit, minus lower limit. Here there is t, so the t, if you put value of t as 0, then this whole term will be 0, minus minus plus e raised to 0 upon s square, this is upper limit and lower limit for first term. Now second term, put upper limit minus 2 square, so what is value of 2 square, that is 4 e raised to minus 2t upon s minus 2 to the 4 e raised to minus 2t, sorry 2s, sorry, yeah, here also minus 2s divided by s square, okay, minus 2 e raised to minus 2s divided by s cube, this is now upper limit, okay, minus lower limit, so minus, so due to this minus sign all the next terms the sign will be changed, okay, all next term sign will be changed. So how to do this, look at this. Now minus lower limit, so this minus will be plus t square, that is 1 e raised to minus s upon s, okay, minus minus again plus 2 e raised to minus s upon s square, again minus minus plus e raised, sorry 2 into e raised to minus s upon s cube. So this is the second term, okay. Now let us try to simplify this. So that is equal to, how to simplify this, minus e raised to minus s upon s minus e raised to minus s upon s square plus 1 upon s square, okay. Now this plus, so plus minus minus 4 e raised to minus 2s upon s minus 4 e raised to minus 2s upon s square, okay, minus minus, okay, this we have completed. Now this minus 2 e raised to minus 2s upon s cube plus e raised to minus s upon s plus 2 e raised to minus s upon s square plus 2 e raised to minus s upon s cube, okay. Now whether any term get cancelled or not, check this. So this term and this term, this is minus, this is plus, so this term get cancelled, okay. This is minus e raised to minus s upon s square, this is plus 2 e raised to minus s upon s square, okay. So here definitely 1 e raised to minus s upon s square will remain, isn't it? Now here again, so this term and this term get finished. Now here 1 upon s square is there. Now here 2 e raised to minus s upon s cube. So there is no such term in the first term, so let us keep it as it is, and now write down the remaining terms as it is. Okay, yes, or okay, no way. Now here we have to keep it as it is. So 1 upon s square minus 4 e raised to minus 2s upon s minus 4 e raised to minus 2s upon s square, okay, minus 2 e raised to minus 2s upon s cube, okay, plus 2 e raised to minus s upon s square plus 2 e raised to minus s upon s cube. So in this way we have to find the Laplace transform of that given function. Okay, so I hope you understand this. Okay, now let us take some examples for homework. Example number 3, find Laplace transform of f of t if f of t is equal to t plus 2 for 0 is less than t less than 1 is equal to t 1 is less than t less than 2, okay, and that is equal to 0 for t is greater than 2. Example number 1. And next example number 4, find Laplace transform of f of t if f of t is equal to sine of 2t, okay, for 0 is less than t less than pi, okay, and is equal to 0 for t is greater than pi. So you try this example. If you have any doubt, you can ask in the comment section. Okay, thank you very much.